All right, guys, this video is, I've lost my pen. What's up with that? Here we go. This video is from handout number 1. It's on box plots and histograms. I think we'll be through with this in about 10 minutes. So these are the kind of videos you like, right? So what we've got a box plot displaying the number of miles, the range that 21 randomly selected airplanes can travel when filled with fuel. Filling the plane with fuel sounds like a really good idea to me. Use the box plot to answer the following questions. So approximately what's the value of the median? Well, guys, when you have a box plot like this, first thing I see is we have an outlier. So we have some plane out here that can travel an extraordinarily long distance with a full tank of fuel compared to the others. But nevertheless, we have this is comprised from the 5-number summary, where this value right here is the lowest. This value right here is Q1. This value right here is the median. This value right here is Q3. And of course, this value right here is the highest number. A lot of people want to come in here and say this is the highest number, but it's not. This is the highest number that is not yet an outlier. But this number clearly is bigger than this number right here. So we could say that there's a plane that has approximately 3,000 mile range in our data set, but it's not the biggest, because this out here at 5,000 is the biggest. But this plane right here at 3,000 is the biggest. It's not yet an outlier. And there's no planes that have travel or distance range between 3,000 and 5,000. Because if there was, this line would be drawn out, or there'd be a dot there. So anyway, approximately what's the value of the median? Well, that's that line right there. I'm going to call that, I don't know, this is 1,500, so I'm going to call that about 1,100. If you said 1150, fine. If you said 1050, fine. If you said 3,300, we got a problem. Approximately what are the values of Q1 and Q3? Q1 to me looks like it's about 600. And Q3 to me looks like it's about, I don't know, 2,200. If you say 2,100, that's fine. I'm going with 2,200. This right here is 2,500. And it's just a little less than a half, so that's why I went with 2,200. So approximately what are the values of the 5-number summary? Well, we got some of them. But the lowest value here looks like to me it's about 400. Q1 is 600. The median is 1,100. Q3 is 2,200. And the biggest value is 5,000. So guys, remember the 5-number summary is the smallest number, Q1, the median, Q3, and the biggest number. Part D, approximately what's the value of the IQR? Well, guys, remember the IQR is just Q3 minus Q1. So I've got 2,200. For the approximate value of Q3, I have 600. For the approximate value of Q1, so we can say that the IQR is approximately 1,600. Now, guys, again, the IQR stands for, it's the distance from here to here. So it's the range of the middle 50% of our data. Now, why do we care? Well, we want kind of a stable measure of center. This central focus of our data, this middle 50%, what's the range of it? Unaffected by all these seemingly larger outliers. So approximately 25% of the data fall above. Well, that's going to be Q3, because we have 25% of our data is above Q3. So we said the Q3 was about 2,200. So approximately 25% of our data falls above 200. Are there any outliers? Yep, there's one. And if so, how many? Well, there's one. And what's the value? Well, the value is approximately 5,000 miles. All right. Number 2, we have a histogram here. So in a statistics class with 136 students, professor records how much money each student has in their possession during the first day of first class of the semester. The histogram shown below represents the data he collected. So what is the shape of the distribution? Well, guys, this is clearly positively skewed. Let me go back over one thing here. You got to remember that our histograms are drawn on the rectangular coordinate system, where this is the x-axis and this is the y-axis. These are positive numbers, these are negative numbers, these are positive numbers, these are negative numbers. These histograms are drawn in here someplace. Skewness is defined by the tail. So if we have a histogram that looks like this, if we smooth that thing out, the tail is in the right side of the distribution. Whatever direction the tail is pointing into, in this case toward the positive numbers, that defines positively or negatively skewed. For example, if I had a distribution that looked like this, smooth it out, the tail is pointing toward the left, which is going toward the negative numbers. So it's all about the tail. There's some song out now that annoys the crap out of me. It's called All About That Bass. It's not really that bad, but it kind of is too. Well, it's not even out now. It's out. It was probably out like 2 years ago, but or a year ago, whatever. But anyway, it's kind of catchy, but it's also kind of annoying. Sorry, Megan, if you're sitting around stalking my statistics videos and watch my videos, please don't take any offense to that. All right, gang. Between what two amounts of money will the median lie? Now, I tell you, this is a hard problem, because what you got to do is you've got to think that if we have the 136 students and we have the lowest amount, and we can arrange these values all the way up to the highest amount in what we call ascending order, well, the median would be the number in the center. Well, we got to think that that number, if we could give these students an ID number, so that lowest number that the person has, probably 0, we give that person a number 1, and the next person could even be a 0, number 2, and the next person a number 3, and then up here we have 135, and the person who has the most number, we'll give them a 136. Because guys, remember, right up here it says we have 136 students. What would be the location of the median? Well, it would be half of 136. Which would be the 68th student when these students are arranged from low to high. Well, guys, where is the 68th student going to fall? Well, in this section right here from 0 to 10, we can see that there's 61 students. By bringing that line over to the axis, we can see that there are approximately 61 students. So these first 61 students, these students right here, they fell in there. These next, from 10 to 20, these next, what would you call that, 42 maybe? These next 42 students fall in there from 10 to 20. Well, what we're looking for, this 68th student has to fall in the 10 to 20 range. So guys, the amount, I've messed this up, but I think you can still follow. So between what two amounts will the median lie? Well, guys, it'll fall somewhere between 10 and 20 for the reason I just explained. Approximately how many students have between 20 and 30? Guys, this is an easy question. We go to 20 to 30. We come up to the top of the bar, go over, and we see that the frequency is 20. Approximately what percentage of students have between 20 and 30 in their pocket? Well, we have 20 out of the total of 136. And guys, I'm going to grab my calculator here. And when I do 20 divided by 136, I get 14.7%. All right, would you expect the mean to be smaller, larger, or approximately equal to the median in any positively skewed distribution? The mean will be greater than the median. And I am going to explain that a lot more in the next video. Okay? So that's a great segue. Guys, that's it, I think. Make sure there's not another sheet of paper. Yeah, that's it.